Uh, the conservation department at the IMA is divided into four main areas. So we're in the paintings conservation lab here, and this will be paintings, easel paintings, as well as panel paintings. In fact, the department runs also a regional center where they treat items from the surrounding region, Indiana, surrounding states, and that often involves a lot of murals and fresco restoration. So paintings conservation. We also have paper conservation, which is back in this area. That's going to be prints, drawings, photographs, etchings, as well as Chinese scrolls, Asian paintings, screens. We have objects conservation, which is any three-dimensional object. It could be sculpture, glass, metal, a lot of modern design materials and decorative arts. And then we have textiles conservation. So upholstered furniture, tapestries, costume, fashion, and now conservation science. And the science is being added to the conservation department as a way to provide some analytical expertise to be able to identify materials, to conduct technical studies of key pieces of the collection, to perform technical art history, to work some on authentication and attribution, and also to do novel research, either applied research or fundamental research, trying to understand better the nature of artist materials, the mechanisms of their degradation, the rates of degradation, looking at different approaches that might be able to arrest degradation or restore a damaged artwork. So all of that's going on in this area.
Can you tell me about a project that you've been working on recently?
Well, the lab has been the main project, creating the actual physical space for the conservation lab. I've only been here since the early part of January, so in that period of time we've gotten together with architects, we've planned the space, we've been researching analytical instrumentation, making those purchases, and then largely devoted to just getting the lab ready, up and running. But we do have a couple projects that are in the pipeline. We've been working with curators and conservators to think about some technical art history projects. A good example is Gustav Baumann, who was an arts and crafts period printmaker, largely in Chicago, but the museum owns a substantial collection of his prints. He made his own artist materials, his own printing inks, and so there's interest in trying to find out the pigments and dyes that he was using. We of course want to understand their light stability, how do we exhibit these things safely, and then there are also condition issues related to his works, or things that we could look at in a more scientific way in terms of the degradation of the artist materials. So that's a potential project we've been talking about. And again, once the lab is up and running, then we can pursue those things.
Okay.
Let me take you on through another part of the lab. We're headed back towards objects conservation and textiles. So a number of the conservators are out right now, but textiles conservation, as I mentioned, is going to deal not only with fashion arts and decorative costume, but also upholstered furniture. So the upholstery on this set of chairs and sofa is being recreated. And then we have ethnographic textiles, rugs, and traditional garb. All different types of textile materials fall under this department's care. Sorry, there's not a lot visible right now because they keep everything covered in Tyvek to keep the dust off of it. Obviously, if dust accumulates on the textiles, then you have to interact with them to clean them, and that's one of the largest sources of damage for most art materials is interaction with people. So if we can keep things clean through preventative measures, we try to do that. But they have a lot of the typical equipment for a textile lab, very large sinks where they can do wet chemical treatments, washing of textiles. They do dyeing in here to generate replacement textiles to patch and mend. They do a lot of structural repairs on textiles. And I wish the textile conservator was here. Turn the description over to her. So this is the Objects Conservation Lab, where work is done on furniture, on ethnographic objects, on fine arts and decorative arts, as well as modern design materials. Here's an example of a research project. This is not a conservation project, but looking at these African Songhay figures to try and understand their internal structure. So if you look at these, Richard McCoy, the objects conservator, has been radiographing these objects to try and figure out how they were carved out internally. So they all have digestive tracts that go from the top of their head, through their mouth, their belly button, all the way down to their anus.
Wow.
And these were living objects. They were fed a magic material. And so part of the question is, what is the substance that's inside of them? How are they carved? Looking for tool marks, etc. And use a number of non-invasive diagnostic techniques. So radiography, a long video fiber scope so that you can probe down inside and see the structure and look for tool marks on the interior. So
could you explain exactly what radiography is?
Radiography is akin to what happens when you go in for a medical x-ray.
Mm-hmm.
It's, we'll see the instrument here in a minute, but it uses x-rays from an x-ray tube and film to record the x-rays, and the object is placed between those, and if the object has radio opaque material, they block the x-rays. If it has radio transparent material, the x-rays go through. And so you end up with an image just like a medical x-ray, and that tells us something about internal structure, because a lot of these materials transmit x-rays. Here's an example of a radiograph. We have a digital radiograph instrument, but this is one of the Songhay figures, and hopefully you can tell the different contrast levels between this area of the stomach and chest and the long tube that seems to be running through it. This is part of that digestive tract where the carving has gone down through the body. It's intersected here from the mouth. You can see it's intersected from the belly button, and then it's harder because of the density here of the buttocks area, but it actually comes out all the way to the hind end as well. These objects have bits of metal nailed into them, and so you can see they're far more opaque to the x-rays, so they show up white. That is, the film is not developed there. And so you can see the nails, you can see the bits of metal that have been hammered into the face. Has a beaded and braided necklace, and you can make out those in the radiograph. And then the little grass skirt down here even shows up. One of the great things about a digital radiograph system is with one exposure, using digital modifications of the image, you can make out all these different levels of contrast and really get a good idea of the internal workings, what is hidden to the naked eye. We use this on all sorts of objects, not only sculpture like this, but paintings. One of the most common pigments that's used in traditional paintings, oil paintings for instance, is lead white, which is a basic lead carbonate. So it gives you a nice radio opaque image. And the lead white was mixed with other colors to create different tones. And so when you do a radiograph, you'll see not only aspects of the topmost image, but if there are subsequent paintings underneath the topmost image, they too will appear. It's one way that we can find hidden or lost paintings that were painted over at some point. We can look at structural problems with paintings without having to be invasive. And there are a number of other imaging techniques that are used in a similar fashion.